that you can look at this one. How did you guys go after this one? What do you think?
I just got rid of the cube root with 6,
Okay.
which would give you 25 x squared and y squared.
Okay, you're doing a bunch of steps at once, and that's fine if you can handle that, but I want to show so everybody else can follow along. So if we're going to put this back in its exponent form, that 3 goes under there, right? So since this is all parentheses, so I'd actually have 5xy to the 6 over 3 power, which we know is 2. And then what? This gets distributed to all of these. So I'm going to get 25, because that's 5 squared, x squared, y squared. That's one way to do it. Did anybody do it differently? Does anybody see another way that you could do it?
Yeah, distribute.
Put the 6 through first, and then it becomes one of those good stuff, bad stuff problems. So either way. All right, 35. This one, we can rewrite that because 1.5 is really 3 halves. So if I rewrite this in its root form, yeah.
I did a little bit differently. I split it up into, I don't know if this will already work. I split it up to like 4 to the first times 4 to the half.
That'll work for this one because you would add the exponents. Yeah, that's okay. You should end up with the same thing. Did you get 8?
Yeah.
Okay, that works. Okay, so if I put this in its, if I rewrite this number now in its root form, what will that look like? Square root of 4 cubed. And the square root of 4 is 2, and 2 cubed is 8. Takes us to 37. Same idea on this one, so if I were to rewrite this, it'd be 10,000 to the 3/4 power. Now if I rewrite that in its root form, what does that look like?
The fourth root of 10,000.
Okay, and what is the 4th root of 10,000? 10 cubed is 1,000. Right, so same idea. 57. Okay, again, this is the same type of problem. So if this was 64 to the negative 1/2, instead, the first problem that I want to fix is I don't like that negative exponent. So how do I fix that? Okay, so what will this problem be then?
1 over 64 to the 1/2.
Okay, and when we have something to the 1/2, we know that's something else. Square root of 64, which is 1 over 8. Right, this is kind of, you really don't really need this 2. So I kind of just want to deal with this right now, and then I'll multiply whatever I get there by 2 at the end. All right, so if I rewrite that in root form, it'll be the 4th root of 16 cubed. What is the 4th root of 16? So 2 cubed, 8. And then I had this 2 out in front, so I get 16. So a little bit trickier, but not too bad. Okay, lots of ways to do this one, now that you guys have so many exponent rules. So what's one way that I could start this one? What's one way?
Could change them into radicals.
Okay, both the top and the bottom?
Yeah.
Okay, so what will this top one look like if I make it into a root form?
Cubed roots of 1,000 parentheses to the 4th power.
Okay, over.
Square root of 100
Okay.
to the 3rd.
Okay, now what is the cubed root of 1,000?
10.
So this is 10 to the 4th over,
10 to the 3rd.
and I have the same base, so what do I get to do with their exponents?
Subtract them.
So 4 minus 3.
4, so you get 10.
That's one way. Now the other way, kind of think about it is can I rewrite 10 or 1,000 so that it's and 100 so that they have the same base. What is 1,000? How can I rewrite that? 10 to the what? Third. And then that, so this is still 1,000, right? I just changed the way it looked. And so it's still being raised to the 4/3 power. Same thing down here. I could rewrite 100 so that it's 10 squared to the 3/2 power. Now what do you do with power to power? Multiply them. So these 3's will cancel and I'll get 10 to the 4th over these 2's will cancel, I'll get 10 to the 3rd. I get the same thing. So a couple different ways to think about the same problem. I don't really care how you get at it. They both work. Any other ones? Okay, 7.5. Pretty short lesson today, actually. The rules really haven't changed anywhere since Algebra 1, when you guys were doing problems way back when. The bottom line is to get x by itself. So you need to get everything else around it away from it. I mean, we've gotten a lot more complicated in what I do to the x, but all in all, the rules are really the same as what they were before. So how do I start getting things away from the x right now?
Subtract 2.
Okay, so subtract 2 from both sides. That'll get me a square root of 3x minus 2 equals 4. Now what?
Square both.
Right, because I need to get this x out from underneath this root. So I need to undo a square root by squaring it. So what do I get? On the left. Okay, so I just get that without the root now. And on the right? Right, and then it becomes real easy. Yep, add 2 to both sides. So 3x equals 18. So what's x? 6. Easy. All right, how about this one?
So the radical x parentheses.
Yeah, you need to get it out of the parentheses. So when it was a number that wasn't a, well, let's look at this one because I have a fraction. So this one's a little bit different. What should I do first?
5/2.
Okay, once you get to this point, you've got a couple different ways that you could look at this problem and decide how you want to go at it. What's one thing that I can do? Okay, and this is not the way that I would choose to do it, but that is one option. So how would I rewrite this in its root form? Cubed root x minus 2 squared. Okay, and then we go from there. So now what would I do to both sides? Square root to get rid of that. So that's going to get me the cubed root of x minus 2 equals positive negative 5. Now what? Well, we'll just go with 5. It'll be easier. Okay, now how do you undo a cubed root?
Cube it.
Cube it. So now I've got x minus 2 equals 125. Add 2 to both sides. X equals 127. Okay, that's one way. That's not what I would have done. Way 2, I am still back here. X minus 2 to the 2/3 equals 25. Right? What would I like this exponent to be? 1. So if I were to raise this whole side to some power, what would I have to raise it to in order to get this to be a 1? Close. 3/2. Because then the 3's and the 2's will cancel, right? But if I do that to one side, I've got to do that over here. Now I've got an x minus 2 equals a 25 to the 3/2 power. Now how can I rewrite that? Square root of 25 cubed. So x minus 2 equals square root of 25. 5 cubed. 125. Add 2 to both sides. X is 127. Right? They're both about the same length. Doesn't really matter which way you go at it. So you have that option. So if you just want to get rid of that exponent right away, you can raise this whole side to the reciprocal, power, and then it'll simplify out the same way. You'll get the same answer. Up to you. All right, how about example 3 here?
That's 2x's.
I have an x on both sides, right?
Subtract 5.
Okay, so that hasn't changed. All right. Okay, so if I square both sides, if I square this side, I'm going to get an x minus 3. When I square this side, what do I get?
Foil.
I have to FOIL. Good. So this is really x minus 5 times itself. So I'm going to get x squared minus 5x minus another 5x plus 25. So I get x minus 3 equals an x squared minus 10x plus 25. Okay, now what?
Add the 3.
Yeah, get everything onto one side. We're going to actually get rid of both of these things. So I'm going to add 3 and subtract 1. 1x. So I'm going to get 0 equals x squared minus 11x plus 28. What's my only option? Well, you have 2 options, I guess. Try to factor it, and what if it doesn't? Quadratic. Will it factor? Yep. What do you multiply together to get 28, but adds together to get 11? So what makes this 0?
7.
This one? 2 answers for that one. Now, anytime you get 2 answers, you should be leery of it. Sometimes you will actually get 2 answers that work, but if you get 2 answers, you should always put them back in and make sure that they make sense. All right, so if I take my 7 and plug it in here, I'm going to get 7 minus 3, that's 4. Square root of 4 is 2, plus 5, that's 7. Is that what I would have gotten if I plug in a 7?
No.
Yep, that one's okay. So I plug the 4 in here. 4 minus 3 is 1. Square root of 1? 1. And then 1 plus 5? 6. And that's supposed to be a 4. This one's out. This one I get to keep. All right, so always be careful when you get more than one answer. You should, for these type of problems, you should be, one of them probably doesn't work. Sometimes they do both work, but most of the time they don't. All right. What do you think on this one? Nice.
First square root first and cube root the second.
You mean rewrite them, or do you mean actually square them? What do you want me to do?
I guess square them, just keep square zero.
Well, I can't square both. Remember, I am allowed to square an entire side. That's okay. I don't really want to FOIL this. Yep.
Got a 3x plus 4 to the 1/4 power on the other side.
Okay, this is one way to do it. So 2x plus 1 to the 1/2. And if I add this to both sides, I'll have a 3x plus 4 to the 1/4 on both sides now. Okay. Now what? What's making this hard?
2 exponents.
So make them both 4?
Both of the denominators?
Yeah.
There's an even better way, but you're on the right track. So what could I do to both sides in order to eliminate those fractional exponents? Could I raise this to some power?
Yeah, 2.
Okay, what would I raise this one to? 4. But if I'm going to do it to one side, I want to do it to both. So which one takes care of both, the 4 or the 2? The bigger one. So if I raise them both to the 4th, what power am I going to get over here?
1.
So now I just have a 3x plus 4 over there. What about over here?
2.
2, so I've got a 2x plus 1 squared, but it's better than a fraction. All right, now what do I do with this? FOIL it. So 2x plus 1 times a 2x plus 1 equals a 3x plus 4. So that's 4x squared plus 2x plus another 2x plus a 1 equals my 3x plus 4. That's 4x squared plus 4x plus 1 equals 3x plus 4. Now what?
Subtract by 3x.
Okay. So now I've got 4x squared minus, or plus x minus 3 equals 0. Think that factors? Maybe.
Yes.
That would get me a 4x squared, a plus 4x minus 3x. Yeah, that works. What makes this one 0?
3/4
What makes this one 0?
-0.
Negative 1. So now we're going to want to double check, make sure those will actually work in my solution, so if or my original problem. So if I were to plug the negative 1 back in here, alright, so we're going all the way up there. If I plug a negative 1 in there, I'm going to get 2 times negative 1. It's negative 2 plus 1,
-1.
negative 1, and I'm taking the square root of that negative 1. I already have a problem. That's imaginary, right? So that's out. So we know you are not a good answer. 3/4. If I plug 3/4 in here, 3/4 times 2, 6/8, which is 3/4. No, wait. Not 6/8. What am I agreeing to here? 2 times 3/4. 6/4, which is 1.5. Okay, and then 1.5 plus 1, 2.5, and I want to take the square root of that. That'll give me a real number, right? Okay, and if I plug 3/4 in here, 3/4 times 3 over 1, that's 9/4. That's actually 2 1/4 plus 4, so that's like 6.25. And I want to take the 4th root of that equals 0, right? That makes sense. At least I'm going to get real numbers. Okay, so we're all right for this one. So that's a keeper. But again, I ran into this problem where I have 2 solutions, but one of them probably isn't going to work, and it didn't because I got an imaginary. Okay, so just be leery of those. If you end up getting more than one answer, check them for sure. If you want to check the ones that you just get one answer, if you're not real sure, sometimes those won't work either, but almost always do. Homework, page 394, 1 through 29 odd, and then 35 through 49 odd. Check those answers in the back. That'll help you narrow down whether some of those solutions don't work either.